Let's solve the following equation. So the equation is given by x squared minus 4y squared equal 36 with x, y in z. So this kind of equations, we try to factor out this left side and factor out this right side in prime factorization and make sure that we get the products. Okay, so where 36 can be written as 1 times 36, but since we are in z, it also can be written as minus 1 times minus 36. It also can be written as 6 times 6 minus 6 times minus 6, and also can be written as 2 times 18 or minus 2 times minus 18, or can be written as 9 times 4 or minus 9 times minus 4. And I think that's all. Are there any? None. I think that's it. Okay, this left expression can be factored as x minus y x minus y times x plus 2y equals 36. So if we have to solve this one blindly, okay, we have to go through all this one. Okay, so for every one, we have how many cases? 1, 2, 3, 4, 8. 8 times 2, that's 16. We have to solve 16 different systems, and we'll find the solution. We can eliminate the one that we don't need, because sometimes we are not gonna find all the solutions. Okay, but in our case, we notice that the product here, 36, is an even number, and we can get an even number when we do the following. So this one is multiplied by 2. That means it's an even number times something. It could be an even or odd. So if we have two numbers, 2k times 2k prime, these two numbers are even. So we get this new number. I have to keep these 2 to make sure that's even. So it's going to be 2 times t. So the product of two even numbers is even. We can also have 2k times 2k prime plus 1. So this is an even times an odd. So we get 2 times 2k prime plus 2k. And we factor this one out as 2 times 2k prime plus 1. 2k k prime plus k. So this one gives us an even number. Let's call this whole number t. Okay. I can also have 2k plus 1 as an odd number times 2k prime, which is an even, and I get an even number. But there is one key here. Look at these two numbers, 2k times 2k prime. Their product is even, but notice the sum. So the sum here of these two is even, but here the sum is odd. Here the sum is odd. Here, well, notice x minus 2y times x plus 2y. The product is even. So what about these two numbers here? What about the sum? So x minus 2y plus x plus 2y is 2x. It's even. The sum is even and the product is even. That means these two numbers are even. They are not. We don't have these two. We eliminate these conditions. Okay. So we eliminate this case. We eliminate this case. We only left with these 4 cases. Okay. So that's why we have to solve. I'm gonna solve this first one. X minus 2y is 6. X plus 2y is 6. When you add them, you get x is 6 and y is 0. So 6, 0 is a solution. Okay? We can have a minus 6, minus 6. We can have, and in this case, we get, let's solve it. X minus 2y is minus 6. X plus 2y is minus 6. And when you add these two equations, you get 2x is minus 12. That means x is minus 6. And y is 0. Okay? That means minus 6, 0 is also a solution. I'm going to do one more. So this one here, when I have 2 times 18. So I have x minus 2y is 2, and x plus 2y is 18. So I add these two equations, I get 2x. This one is always 0 because 2y minus 2y is 0. So I get 20. So that means x is 10. And I solve for y, I get y is, so 10, that means y is 2. Let me solve it. So 10, let's solve here. So 10 minus 2y is minus 4. That means y is 4. Sorry, y is 4. Sorry. It's minus 8. Y is 4. So that means I get solution, another solution as 10, 4. Okay? So we have one more case, we have 3 more cases left. X minus 2y is minus 2, and x plus 2y is minus 18. Okay? And the other case, x minus 2y is minus 18, and x minus 2y is minus 2. Okay? Anyways, you get the idea. So I found 3 solutions. You can find all the other ones. This is how we eliminate all these ones. This is how we solve an equation in the set of Z. There is no standard way, but every problem has its own way. But in general, you can find like a lot of equations like this that you can solve. Thank you.